Company Ecos presents. New product of the company Ecos, zero emission stations with a capacity of 5,000 to 60,000 cubic meter per day using biological method of cleaning. These stations are a major breakthrough in the construction of treatment facilities for large and medium-sized cities and settlements. The peculiarity of these stations is that they house all the necessary technical processes of cleaning and secondary work areas in a closed space, while excluding emission of harmful substances into the air. Superstructure block of the plant can be made up of various building structures and elements based on the productivity and features of the project. The stations consist of substructure and superficial structure. The substructure is a high-quality cast concrete structure and primarily serves as a store for basic technological processes of purification. The depth of substructure and age of the superficial structure may vary and depend on the productivity and the hoisting equipment to be used. Optimal dimensions for a station with a capacity up to 60,000 cubic meter per day are: overall diameter of the station up to 80 meters, depth of the substructure 8 meters, elevation of the superficial structure 6.5 to 9 meters, depending on the specifics of the project. Main stages of the contaminated sewage treatment are: mechanical treatment, biological treatment, profound after purification, disinfection, treatment of the resultant sediment. Among necessary auxiliary working areas and facilities we find: accommodation space with a laboratory, cellar for equipment and reagents, areas for handling operations, and others. First, sewage water undergoes through mechanical cleaning. Afterwards comes the biological stage of cleaning, and untreated wastewater streams into secondary settling tank equipped with thin layer modules. Thin layer modules allow intensification of precipitation of water impurities, increasing efficiency of settling tank use. In order to remove accumulated active sludge from precipitation tanks and create a recycling circuit, submersible drive pump units are installed. Surplus sludge is picked up from the recycling circuit pipe of each cleaning line and is served into the concentration tank. After the secondary settling tank, the supernatant pours into the two-step gravity brash anthracite coal filter on trays. Filtration is carried out top-down. The first stage of filtration is carried out through synthetic wood of brushes having high retentiveness. Cleaning is carried out via biosmosis of attached microorganisms that provide oxidation of residual impurities. In order to provide the microorganisms with necessary oxygen, the synthetic wood is regularly aired through membrane aerators. The second stage is the anthracite filter. Wood of the anthracite coal filter provides a more thorough treatment of wastewater, clearing it from finely dispersed suspended matters that escape the brush filter. Wastewater, after purified in the brush anthracite filter, has undergone a high-quality cleaning process and can be used in aquaculture of first or even higher category, or can also be used for various technical needs. For more thorough treatment of the sewage water, a solution of specially selected reagent is dosed into water before it enters the filter. Further disinfection may be carried out with ultraviolet lamps or using sodium hypochlorite solution on the customer's request. After profound cleaning and disinfection, sewage water is sent to the discharge point or to further use. Intensified surplus sludge is dewatered with the help of centrifuges. The sediment dewatered in centrifuges is suitable for any form of further technological use and is removed with the help of specialized vehicles through the storage bin. The sediment may also be dried until moisture content reaches 10% on blades. Drying is carried out by the conductive method, which reduces ignition and explosion risks to zero. Diathermic oil or vapor can be used as a heat transfer agent. After drying, the sediment in the form of coarse powder is fed to the cooling plant, where it cools to a temperature of about 40 degrees Celsius. The resulting product in the form of coarse powder can be used as solid waste in the production of building materials or as raw material for heating. The station is equipped with heating and ventilation systems. Air intake is carried out through air supply units with built-in filters and air conditioners, regulating the temperature inside the room. Stations are completely closed. All the water treatment processes take place in the same room. Harmful gases are caught and neutralized by special filters. No noise pollution takes place. Thanks to the lack of harmful emission, the sanitary protective zone around the treatment plant is reduced to a minimum. All the air pulled out of tanks is clean and decontaminated. Special decontamination equipment is used for this purpose. Air purification is achieved by applying electric charge on the molecules of gases. All technological pipelines and trays are made of stainless steel. Sewage water in zero-emission plants is purified to the highest standards on the customer's request and can be used hereafter for washing the streets and watering the woodlots or for industrial water supply. Treatment facilities can be fully automated, or they can be controlled by the operator who sits in the control station and watches the processes with the help of observation cameras. Without changing the flowchart of purification, we change the place of technological equipment and production support areas, ensuring complete localization of harmful air emissions. The resultant constructions are equipped with leak-proof air ducts for taking air emission to electric catalytic cleaning, whose equipment is also on the second level in the center of the construction. Extraction of air emissions from the first level is also carried out with the help of leak-proof air ducts and is taken to electric catalytic cleaning too. The released space can be used as warehouse space, provision of necessary facilities of interior, or it can even lead to redesign of the sewage treatment plant building, significantly reducing capital costs for construction of the station. Zero-emission stations significantly differ from classic examples of current treatment facilities in that they can house all technological processes for high-quality treatment of various flows in a closed space. Besides, they utilize waste sludge and sediment. These stations are capable of processing harmful emissions, excluding their leakage into the air. They are more environmentally friendly than classic circuits with open systems of aeration, settling tanks and sludge fields. A variety of architectural and design solutions can be used in the construction of zero-emission stations. Design of these stations can be fitted to the architectural landscape of existing structures and buildings, cities and settlements. Zero-emission stations can also be installed in any climatic zone under all weather conditions, temperature and seismic regime. Zero-emission stations are much more efficient in terms of economy, capital investment, operating expenses and cost price. company Ecos.